All right, we are looking at Unit 2. Today we're starting the topic of significant figures, starting in Section 5. I am going to divide the significant figures into two different videos. This is the beginning of video number 1. First thing, it is impossible to make a perfect measurement. We can use a meter stick and we can measure an object's length. Like a desk. We could measure a desk in terms of meters or centimeters. If I wanted to measure the width of a pencil, I could do it in millimeters. All of these measurements would be fairly accurate to some degree. We may have to estimate to a fraction of a millimeter with the pencil, or maybe a fraction of a centimeter with the desk. But we can be confident that our measurement is fairly accurate. So I'm going to take some measurements here. I am in the classroom and I have just a standard yellow pencil and I have a meter stick. So taking a measurement, I would say this pencil is approximately 7.5 millimeters in diameter. Could I measure it in micrometers? One micrometer is 10 to the negative 6 meters, or you could say 10 to the negative third millimeters. So like 1/1000th of this. I could make an estimate with a conversion. 7.5, this is millimeters, and to make it micrometers, it's just times 10 to the minus third. A conversion is possible, but could I actually measure it? Can I look at the markings for millimeters, of which there's 1,000 on my meter stick, and accurately determine with confidence that my pencil is, let's say, 7,462 micrometers. I have 1,000 markings on this meter stick. They go down to millimeters. But each one of these tiny millimeter markings would need to be divided 1,000 times for me to get a good measurement like this. So what we would say about this is that my measurement is much too accurate for the measuring tool. The last 3 numbers in my measurement, these are all estimated. Because if you were looking at the meter stick like I was, so here's the surface of the meter stick, here is 7 millimeters, here is 8 millimeters. The pencil looked like it fell somewhere in here. So even this 0.5 is an estimate. It's an estimate because there's not a line for 0.5. If it were maybe a little bit over here, and let's specify 7, 8, this might be 7.7, it might be 7.8. That last number is going to have to be estimated because there's no lines for us to guess with. You could probably say this is 7.5, but if I were to look at this, I would tell you I don't think that's 7.5. Maybe 7.6, maybe 7.7, maybe 7.8. But I don't think it's 0.5. But the last digit is estimated. That's really up to the person who's doing the measuring. So a measurement cannot be more accurate than the measuring device. When I talk about this in the classroom, which I will because this is an important topic, I'll show you the tool that I have in my hand right now. This is a very old set of calipers. And the reason I can tell they're old is because they're made out of cast iron and they say USA on it. So probably pretty old. So a pair of calipers, what you do is it basically pinches whatever you're trying to measure, and then you take a reading. So this is telling me that my pencil is, let's see, there's 6 millimeters, 0.24. What these calipers are telling me is that my pencil is 6.24 millimeters. This is quite a bit different than the 7.5 that I guessed. The reason there's a difference is because what I did with the pencil and the meter stick is I'm holding it up here and there's all these tick marks and I'm trying to line it up with one side while I'm reading it on another side. It makes it very difficult. What's going on with these calipers, they look something like this. And it's got a moving piece and it's got this little crank that makes the measurement. This is where I'm reading it. So I put my pencil in here and this is reading 6.24. And really I could guess one more digit and I'm going to say it's 6.241 because that's kind of what it looks like to me. A measurement cannot be more accurate than the measuring device. A meter stick is not a great choice for measuring a pencil. It's a very small object and a very large measuring tool. My calipers were doing a very good job of measuring, and as a general rule, we are only allowed to estimate one digit beyond the markings that are on the measuring tool. So there was a line for 7, there was a line for 8. 7.5 is reasonable. There was a 7, there was an 8. 7.462 was not reasonable because I estimated 3 digits. What I did was take a measurement that was way too accurate for the tool that I was using. This one, I estimated 1 digit, it was the 1. But 6.24 millimeters is a very sure thing. I added on 1 digit because we are allowed to estimate 1 digit. I had markings for 6.24 and I had markings for 6.25, and it looked like it was just above 6.24, and so I added a digit. That's something we can do. This could have been 2.42. It's possible, but it's understood that the last number in any measurement may be subject to error because it is estimated. So I'm going to draw a few different measuring devices to look at how we're going to read these and how we're going to estimate these. So the first thing, let's say here's a ruler. I'm going to draw it over here. Here's my ruler, and I am going to put a pencil right up next to it. I'm going to measure the length of this pencil. So this ruler should have markings. Let's say here's 1, here's 2, here's 3, here's 4, here's 5, here's 6. Let me change the length of this pencil so we have to estimate. Okay. So we're looking at a ruler and a pencil, and we're going to make sure that this side is flush. We want to make sure they're both starting at the same point. So I'm going to look up here and see where this is going to hit. So my length. It's between 4 and 5, and it's closer to 5. So I wouldn't want to just say 4. It's best if I estimate something here. So a half would be about here. This could be, I'm going to say 4.7, and we're going to say these are centimeters. This is a very short pencil. 4.7 is a good estimate. What if I were to say this pencil is 4.681 centimeters long? And you're looking at my ruler, and it only has markings for 4 and 5. You're going to come along and you're going to say, I don't think that's a good measurement. So X. So this one was too accurate for the measurement tool, and this one was too accurate for the measurement tool. You would say 4.6 maybe. 4.7 is probably a good estimate. 4.8 would be reasonable as well. So 4.7, yes. 4.681 is not a good measurement. In another example, in chemistry, we will often use a device, let me divide here, called a graduated cylinder. So the graduated cylinder is this very long, thin cylinder made out of glass, and it's got these markings on it that go all the way up. And so let's take some measurements here. Let's say that, make an adjustment here. Let's say that we're looking at the middle of the graduated cylinder and not necessarily the bottom of it. So let's say this is the marking for 3.0. Here's 3.1. Here's 3.2. Here's 3.3, 3.4, 3.5, and so on. So I start putting water into this thing, and let's say that the water level is here and looks like this. And so I start looking for measurements. So the first thing I say is 3 milliliters. And if you were my lab partner, you'd say, that's not good enough. And I'd say, how about 3.2? And you would say, well, there is a marking for 3.2, but that's not good enough. These two are not accurate enough, because we can divide this section from 3.2 to 3.3 into 10 little pieces in our mind. That's well within our capabilities as humans, and it's well within our capabilities in science. So I'm looking at it, I'm going to say 3.22 milliliters. And as my lab partner, you would say, yeah, I think you're right. Or maybe you're one of these lab partners who likes to debate, and you're like, no, I say 3.24. And then to avoid an argument, the three of you say, it's 3.23 milliliters, and then you move on. But let's say your lab partner goes a little farther, and let's say this lab partner says it is 3.2351 milliliters. And you're looking at this, and there's lines for 3.2, and there's lines for 3.3, and you tell your lab partner, you can only estimate one digit. You estimated 3. No good. Or your lab partner says something crazy like 3.20479 milliliters, to which you say, no. We have a line for this, we have a line for the 0.2, this is estimated, and everything else is no good. So these measurements are too accurate for our device. Another type of device which you won't use in Chemistry 1, but you will use if you take AP Chemistry, is called a burette. And it's a lot like a graduated cylinder. It's very tall and skinny. And it has to be supported by a special clamp on a ring stand because the bottom of it has this dropper and it has this valve. And it can drop out one drop at a time. It can go very slow. And the difference here is you load it up and then the level is going down. This is something that we won't really see this year, but you might see next year or in 2 years. The significant figures are important to understanding our chemistry data and indicating the level of accuracy of a measurement. Significant figures include all known digits plus one estimated. So when I was measuring my pencil in millimeters, 7 was a known digit. I have a marking for 7. It goes a little bit past the 7. Pretty safe to say we can go further. The last 0.5 is estimated. It's estimated because I didn't have a mark that told me 0.5. It looked like 0.5, so I said it was 0.5. Since I can only estimate one digit, 7.5 millimeters has the maximum number of significant figures that I can use. And here is just an illustration of the meter stick. Here's 6, here's 7, and here's 8. And the pencil fell somewhere around here, and the pencil was all over this way. You're seeing an extremely large version of a pencil. 7.5 millimeters, yes. 7.462 millimeters, no. Only one estimated digit. What are the chances that it could have actually been 7.4 or 7.6? Could it have been? Yes, it could. But the last digit is understood to be a close estimate and not an exact measurement. Significant figures show us the level of accuracy and confidence in our measurement. And remember, our accuracy and confidence is determined by the measuring tool. Just because you're a very confident person does not mean that your measurement is any more accurate. So we have to stick with the accuracy and confidence of the measuring tool.